right, welcome to Algebra 1. We're going to start with 1.1, solving 1 and 2-step equations. This is really a review from middle school. The only thing that should be new is that we need to explain our steps as we go along. Okay. The trick to knowing how to solve an equation is just understanding inverse operations. Inverse operations are opposite operations. So for instance, the inverse of addition is subtraction. The inverse of multiplication is division. So to undo multiplication, we divide. To undo division, we multiply. And one that maybe we don't think of so much is the opposite of having something squared, is taking the square root. Square root cancels out the squared. Right? And I'm not going to spend a whole lot of time on recognizing addition and subtraction. I think you're probably pretty familiar with that, and you'll recognize that without any trouble. But I do want to talk about those recognizing multiplication. It seems like a simple thing, but it can look a little different sometimes in algebra. So when you start out when you're young, they tell you to put an x in between it for multiplication, like 2 times 3. We don't want to do that anymore because that x looks a whole lot like a variable, and we don't want to get confused in solving our equation. So you may see parentheses, like 2 times 3, or a dot between it, like 2 times a, or they could just be side by side, like 5c. Those two things are being multiplied together. So those are all examples of multiplication. Remember, we don't want to use that top one because we don't want to confuse our variables and our operations. Okay. So as long as we've got a good grasp on these inverse operations, solving equations should be a breeze. So let's give it a shot. So looking at a one-step equation, first of all, I have x plus 8 equals 3. Well, to undo the plus 8, to get that x by itself, I have to do the opposite here. The opposite of plus 8 is to subtract 8. But whatever I do on one side of this equal sign, I have to do on the other. So I'm going to subtract 8 over here. If this line helps you, then go ahead and draw it. Remember, whatever you do on one side of the line, you have to do on the other. So that would give me x, 8 minus 8 is 0, so that's gone, equals, and over here I have 3 minus 8, which is negative 5. Keep in mind that you can check your answers as you go. If I plug this back in for x, negative 5 plus 8 is 3, so I know I did it correctly. I would definitely check my answers on assessments to make sure that I have the correct answer before I turn it in. So let's try a second example. So here I have minus 5 with my x. I want to get rid of the minus 5, so the opposite of that would be plus 5. That cancels, but whatever I do over here, I have to do on the other side as well. Once again, if you like the line, draw the line. If it doesn't help you, then don't worry about it. And I have x equals 2 plus 5, which is 7. I can plug back in to check. So 7 minus 5 is 2. I know I have the correct answer. All right, let's try a third one. So here I have some multiplication. I have negative 4 times x. To get rid of the multiplication, I need to divide. So I'm going to divide by negative 4. But whatever I do on the left-hand side, I have to do on the right. So I have x equals 20 divided by negative 4 is negative 5. This next one can look a little tricky, but really all a fraction is division. So I have x divided by 7. To undo division, I need to multiply. Multiply both sides by 7. Here those cancel. I'm left with x equals, over here I have negative 4 times 7, which gives me negative 28. Okay, so the next one has a fraction. To get rid of this fraction, all I have to do is multiply by the reciprocal. So the reciprocal is just what you have if you flip the fraction over. Turn it upside down. So the reciprocal for 2/3 would be 3/2, 3 over 2. So I'm going to multiply by 3 over 2. Those will cancel, which leaves me with just an x over here. But whatever I do over here, I have to do on the other side. So I'm also going to multiply by this by 3 over 2. You can multiply straight across. So 12 times 3, which would be 36, divided by 2, because you have 1 times 2. So this is 36 over 2, which is just 18. You're also welcome to just put this in a calculator. It will also give you 18. Okay. Don't let the fractions bother you. It's not any harder. All right, let's take a look at a two-step equation. First thing I want to do is undo addition and subtraction. So looking at the side with the x, we want to get x by itself. We want to leave this 5 for now, though. This 5 is kind of like a clingy boyfriend or girlfriend. It's real attached. It's hard to get rid of. So we want to get rid of everything else that's on that side first. Okay, so here I have a minus 8. To get rid of that minus 8, I need to add 8. Since I did this on the left-hand side, I have to do it on the other side, the right-hand side of the equal sign also. Here I'm going to cancel, so that leaves me 5x equals 20. Now, step 2, now I'm ready to deal with that multiplication and division. This is 5 times x. To undo the multiplication, I must divide. So I'm going to divide by 5, which gives me x equals 4. All right. Moving down here, same idea. I look for the side with the x. Here's my x. But this one's hard to get rid of. This one's clingy. So I get rid of the addition or subtraction first. To get rid of the plus 6, I need to subtract 6. Whatever I do on one side, I'm going to do on the other. So that leaves me with x over 3 equals negative 10. Okay, now, this time our steps aren't written out for us. So if our steps aren't written out for us, we need to write them down. Step 1, I subtracted 6 from both sides. Then from there, step 2, I have x divided by 3. So to undo division, I need to multiply. I'm going to multiply both sides by 3. Which will give me x equals negative 30. And I can still double check these answers, plug it back in. Negative 30 divided by 3 is negative 10, plus 6 is negative 4. So I know I did this correctly. Okay. Don't let this be hard for the hard part. You're just saying what you're doing each time you do it. Each time you do a new step. Okay. So let's try another one. Looking here, there's just one step I have to do before what we did last time now. Because I have x's on both sides, I have to get them on the same side. Move all variable terms to one side. It doesn't really matter which way you move them, but because positive numbers are sometimes nicer to work with, I usually move the smaller coefficient. So looking at my x's, I have 2x and 10x. Since 2x is the smaller one, that's the one I'm going to choose to move. To get rid of the positive 2x, I need to subtract 2x. Whatever I do on one side, I'm going to do on the other. 2x minus 2x is 0. That's gone. So I have negative 18 equals 10x minus 2x is 8x minus 6. Step 2 is to undo the addition and subtraction on the same side as the variable. So here's my variable. I need to get rid of that subtraction to get rid of the minus 6. The inverse of minus is addition. I'm going to add 6. Whatever I do on one side, I do on the other. So that gives me negative 12 equals 8x. Okay. Now that I've gotten my variables on the same side, and I dealt with the addition and subtraction that was on the same side as the x, now I'm ready to get rid of the multiplication and division. Here, I have multiplication. I have 8 times x. So to undo that, I need to divide. And you can make this a decimal, that's fine. Or you can just simplify. Both of these can be divided by 4, which would give me -3 over 2, or -3 halves for my answer. Once again, to check it, you can just plug it back in everywhere there's an x and see if the left side equals the right when you simplify. And in this case, it does. Now, the ones that we've been working on so far have had one solution, one number that you can plug in for x to make the left side equal the right, like this one right here. So let's do one more example like that. Here I have a 4x and a 2x. I'm going to move the 2x, one, because it's smaller, also because there's nothing else over here, so getting the x's on this side will make our job easier. So I'm going to subtract 2x, which will give me 2x equals 6. From there, I divide. To undo the multiplication, I'm going to divide by 2, because I have 2 times x. So the inverse of multiplication is division. Leaves me with x equals 3. So that has one unique solution. 3 is the only thing I can plug in here to make the left side equal the right. Sometimes, however, we have no solution. We have nothing that would make the left side equal the right side. So in this one, if I started to solve this equation, I'd say, okay, I have x's on both sides. To get rid of this, I'm going to subtract 2x, which would give me 10 equals 20, because both of these would cancel. 2x minus 2x is 0. 10 does not equal 20. That doesn't make any sense at all. If what you're left with doesn't make sense, then you have no solution. Okay, so no solution doesn't make sense. We got rid of x, and what we have is not true. Okay. The other side of that is if we get rid of x, and what we have is true. So here, I can add 3x to both sides to get my x's on the same side. -3x plus 3x is 0. Well, that cancels on both sides, so I'm left with -4 equals -6 plus 2. -6 plus 2 is -4. So I have -4 equals -4. That is true. That's true no matter what x is. So no matter what I plug in here for x, the left side is going to equal the right side. There are infinitely many solutions, or all real numbers. Sometimes we say ARN, all real numbers. Any number would work as a solution. And that's it. That's all it's to it. And let me know if you need any help with 1.1.